Hello everyone. I would like to thank STRV and especially Vojta who invited me to give you this speech about protocol-oriented programming. Protocol-oriented programming is a programming paradigm which is, I would say, pretty new to Swift, but it's pretty common in programming because it's been there for a few years, I would say, but in Swift there's really a whole bunch of new features why we should consider this model and why we should give it a more focus. Protocol is very similar to in Swift is very similar to Objective-C protocols, but with few differences. The huge difference is that, as we will show it later, is that you can actually define even variables, not even functions or methods. You can give default implementation for methods, which is a huge thing, and this is where the whole concept is about. And the next thing you can do in protocols is actually that you don't need to code around a base class, because as you might know, sometimes when you have to refactor your code, it might be really painful to change your base class, because sometimes you just realize, okay, I need this object to be also stored in the core data, and then you will have to change its base class to managed object or any other base class depending on the framework you're using, if it's core data or anything else. For today, I prepared small playground where we will be creating a data model for our brand new game, MMORPG related to ducks. Okay, so here we go. I can find, oh, here it is. Okay. Okay, the first thing we will create is protocols for our ducks. So the first protocol, oh, sorry. Is a duck. Duck has name, which is, sorry, as I tried English keyboard, I'm already switched to it. And we will set that this variable will be only, only readable. We can define also set keyword, which says that the structure class or enum which will adopt this protocol will have to create the accessor and the getter. In this particular case, it's only the getter. Okay, as we all know, ducks are creatures which produce sound which is called quacking. So we will have to give them the ability to quack. We might create a function which will allow them to do that. But there might, in future, you may create a new animal, the whole new breed in your game, which will also need to quack. So we will create a protocol instead. Okay. And of course, ducks swims. So we will create protocol swimmable. Okay, great. And as we all know, all ducks can swim, that's for sure. So we can say that the duck protocol can inherit from the swimmable protocol. And this is a good feature that even the protocols can be inherited from each other, same as the classes. So once I say that the protocol duck extends from swimmable, all every value or every class which will adopt this protocol will also have to adopt the swimmable protocol as well. Okay, so the next thing what we can do is, as I said, all ducks can swim. It doesn't matter if it's some special breed of duck or anything. So we can say that we want all ducks to have the swim functionality. So we will create a protocol extension with the default method implementation where we define that. Extension. So we will extend duck to what is it? Swim. And we will print, sorry, I'm just used to different keyboard, and of course I can swim, I am a duck. Okay, so from now on every class or every structure which will adopt the duck protocol already has the default implementation of the swim method. So let's create some ducks. I will probably copy this one because it's so I can save some time, but I can see cursor. Oh, here it is. Just a second. Okay. Okay, so I will paste it here. And we have three kinds of ducks. The first one is the ordinary duck. It adopts the protocol of duck. And it also adopts the protocol of quackable because, you know, it can make that sound. The rubber duck is the one you take to your bath. It's nice, it's yellow, it's also duck. And when you press it, it also can quack. So it's also adopt the quackable protocol. But here's the ninja duck. It's also a duck, but if it's squeak, he goes out of the disguise. So, you know, they don't want to be hurt. So ninja ducks don't quack. And here's the difference. If we created the base class duck and want some special subclass to identifier for type name. It's weird. Sorry. 26. Oh, sorry. Yeah, it's the next part, but still quackable. Oh, yes, it's the copy paste thing. So as always. Okay, yeah, I will create. Okay, it's the next extension I wanted to create. You can extend the duck, the protocol, but the new feature in Swift 2.0 is that there's a where clause. You may know from a different part of Swift. So I would say I will extend duck where self also confirms to protocol quackable, which means all ducks which can quack will get this default implementation. Okay. Yes, this will do the trick. So, as you can see, you can give the the default implementation to all ducks or only to subset which confirms this requirement, and it's pretty great. And get back to our free ducks. If we create a duck as a base class, and then we would create three different subclasses like the ordinary, rubber, and ninja. You can see they both have they three have different behavior, and as I will show you later, the behaviors can grow with the special breeds of ducks. So there will be there would be a very big problem with implementing. You would have to create special subclasses or what. There's some things like strategy pattern in object-oriented programming, and we will see it later. But still, in Swift, as it was mentioned earlier, in Swift, Apple wants you to create as many value types as possible. So if we created class duck, then we would maybe use it just for inheritance, and it's not needed. So here, struct can adopt a duck protocol. So struct is a value type. So then the protocols are very nice to use with the value types, with the classes, and this goes on with the functional. The protocols goes nicely with the functional programming, as well as with the more object-oriented programming as well. So it depends on how you want to use them. Okay, so I got those three ducks, all with different functionality. And what's next? Okay, and then we'll have this testing code. Okay, we will show this later, and okay. And as you can see in console, we called quack on ordinary duck, quack on rubber duck, and swim on ninja. And this is the result what you expected. But because it's all the default implementations for them. But as you know, the rubber duck in your bath actually don't quack. It squeaks. So we changed the functionality like this. And this probably doesn't surprise you. You just override the implementation. I know it's not big deal, but still you can see that if you need a proper implementation, even though you already have one, it's possible. You know, this is what you know from the object-oriented programming when you have the inheritance and so on. So this is the way how you can do it with protocols. Okay. What's next? And as I said, the number of behaviors can grow, and with each of this behavior, we would have to create another subclass if we were thinking in OOP. But rather than that, in protocols, it's much easier. And I will show you how you can implement the strategy pattern you might know from the object-oriented programming with protocols in Swift. Okay, so I will copy this one. I will put it up here. Okay, what I created. It's a new flyable protocol, which defines that all things, all structures and classes which adopts this protocol will have to have this variable fly behavior and function fly. Why it is mutating, I will show it later. Right now it doesn't have to be, but later on it needs to be. And also I created protocol fly behavior, which is used here. And this is what is strategy pattern. So you will get this from the example, I guess. So I would say that and here's the one behavior, is the wing flyable. So, you know, the duck uses wings to fly. So I will say that ordinary duck is flyable. Rubber duck, I don't think so. You can throw it, but it can fly. Ninja duck, ninjas are pretty awesome, but I would say ninja duck can't fly. So right now, as you can see, we have three, I would say, concrete implementations, but each with totally different behavior. The ordinary duck has all of them. The rubber duck, just two of them, and ninja duck is just a duck. And as you can see, it's pretty easy with the protocols and structs to get this going. And here I get the problem because I don't actually right now adopt the flyable protocol, because I need to implement those functions. I need oops. I need to get it back. Okay. And I will put it here. Okay. What I pasted here is the adoption of the flyable protocol. I created a variable, flyable behavior. I implemented the function which calls perform fly on this behavior. This is the part of the strategy pattern. And in init, I just initialize the fly behavior with the wing flyable, which is the struct I created here. It's the concrete implementation of one flying behavior. Of course, I could have do that in variable definition, but in init, I think it's more clear. Okay, so right now we can test it. That when I say that ordinary can fly, okay, it's flying with the wings, so this works. But as I said, the protocol can be adopted even with the enum, and I think this is pretty cool in Swift. So I will add another implementation of fly behavior. It's my state flyable behavior. It's enum, so it has two cases, on and off. And because it adopts a fly behavior, it also has to confirm to perform fly function. So it's enum, we will take advantage of it. We will create switch. If it's on, I will say, I believe I can fly. In case if it's off, I cannot fly. Okay, so we can try it here. I will say that ordinary fly behavior is state flyable on. Okay, it says the right thing. If I change it to the off, I cannot fly. So this is, as you see, I have flying behaviors. One is implemented as struct, one is implemented as enum. You can, if you want to, you can create another as class or another enum or whatever you want. This is pretty straightforward. But let me show you next example, which is right here, I guess. And that's where the mutating is. What's mutating? Keyword. Since value types as a struct are immutable by default, sometimes you need or you want to actually mutate the inner state and inner values of it, and so Swift can perform these operations. You have to create a mutating keyword in front of functions that actually does the change, and we will have this one there. It's one-time flyable. Perform fly for the first time. The duck don't like it, and the next time you try it for the second, third, fifth, doesn't matter, 100th time, it already says, as I said, I don't want to fly again. So you can see, we will try it here. One time flyable, fly. So it works. It doesn't want to fly again. So as you can see, you can pretty much implement the whole nice modal functionality. And you never know that your game will become a massive success, a huge success, and then you want to create a, I don't know, the airplane expansion, and there you also want to implement a flyable behavior or anything else. And if you have modeled it with the classes only, you would be in big trouble. Right now, only what you can do is create a new structure with the planes and let it adopt all this flyable behavior and maybe another protocols which are suitable more to planes than the ducks. But the same the functionality is common. One useful thing is, and I'm sorry, I don't have a great duck example for this one, but you can also specify the types of the protocols you want to take of the object in argument. I will show it. I will create function. Let's say create accept flyable swimable, which takes one argument, which is something which accepts protocol flyable and swimmable. And yeah, it does some magic here. And when I call it, and I will try to put ordinary here, it should be okay because it conforms to flyable, and because it's duck, it also conforms to swimmable. But if I will try to insert rubber duck here, I get an error. For now on, it's a really error on our side. It's not an error of of an Xcode. As you can see, you cannot invoke accept swimmable with an argument list of type rubber duck. That's pretty much useful. Even though I cannot imagine some good usage in our example, but I will leave it here because I guess STRV will be sharing those playgrounds. So I will leave it here, even though it's not working. And the last thing I want to show is something which is called associated types in protocols. For this one, I have an example regarding to ducks again, but it's maybe not that straightforward, but it will show what it is. Imagine that you have protocol you want to be used, but there's a problem. You don't know which type of some concrete arguments will be, because it can change. For example, because of your game was a huge success, there is an expansion in which you wanted to add a functionality in which each particular duck is an expert or something. And you know, some ducks are experts on integers, some ducks are experts on strings, but you don't know that, and you want to share the functionality within the protocol, but you are not sure how to implement it. And as much as I'm pretty sure that there is a much better way how to implement this behavior, I will just implement it with the associated types so you can see the functionality. So I don't say this is the best way how to implement this kind of things, but it's okay, I guess. Sorry. Okay, so I will copy paste it again. So I will extend our duck protocol with the type alias expertise, which says we have got the type alias. We call it expertise for now, and we got function evaluate item, which takes one item, which is the type of expertise type alias. So let's say we will also add this implementation, default implementation for ducks, because as I said, most of the ducks love integers, so here it is, extension duck. We will extend our duck extension with the function evaluate, which takes integer, and you give the duck an integer, and if it's greater than 10, it says that it's great, otherwise they don't like it. But there might be a small problem, I would say, because the ninja ducks aren't experts on integers. They are not. But what they are experts is are the strings. I'm sorry, I'm also losing cursor too much. I can see it on this one. Ah, here it is. Okay. So I will show you next thing how you can extend a protocol in Swift. One thing how you can do it is plain extension on whole type. Oops. Another way is extension the type where some requirement, like it also adopts another protocol. And the next thing, and they can be combined, as you can see. And last thing, last thing is you can extend a type based on the type alias. So if the ducks are have the type alias expertise equal to string, they will get this default behavior. And for so you can do that, and it's not that nice. I try to make it nicer, but I wasn't that successful. Maybe someone will know. You will have to actually add type alias to all of the implementations. Int, okay, 1, but this one is expert on string. Okay, so now it compiles. So when you have this extension where you are trying to create some concrete implementation, you will have to add this alias. And as you can see, I will say that rubber duck, I want to know your opinion on number 9. And ninja duck, I would like to know your opinion on number 9. Okay, let's see what happens. It shouldn't work. Okay, but it's weird. But I will examine it later. But this is it. This is, if I try to say the rubber, evaluate, and put this string, that definitely shouldn't work. Yeah, so at least something doesn't work. Okay, so this is it. Those are the associated types. The best thing I can imagine, and even Apple has it in the documentation, is the usage for things like stacks, containers, and so on, where you don't know which particular type you will be working with, like for storage or something. And that's probably the finish. I just got one more thing. It's not a part of my session, but as you can see, the enums in Swift are extremely powerful. I would really recommend you to take a deep look at them, because you can really create awesome things with them. For example, it's really great for read-only singleton settings, which you loaded from some plist or XML or JSON, because you can change, you can write them, but you can create things like global read-only settings for whole your application and so on with nice syntax, because you don't have to create a singleton thing. You don't have to instantiate it. You just call the enum dot and the case, and you're done. And also, enums can enums could be used perfectly with the image assets. So you can create an extension on UI image and actually write your keys for your images and just use it as give me UI image, give me dot and the enum value for your image, and it will return it to you. So really examine the enums and protocols. So this is probably everything from me. So thank you for your attention.